Hello, everyone. Welcome to Subway Energy Academy, the training section of Subway Energy Limited. You might be interested knowing more about Subway Energy Limited. This is our elegant logo. Subway Energy Limited is one of the fastest growing power generation and distribution company that is duly registered in Nigeria with its corporate head office in Uyo, the Akwa Ibom State capital. That means you are guaranteed doing business with Subway Energy Limited. We have been in the power sector for decades and in the power generation business. Our name is a label. We keep innovating to make sure we give our esteemed customers the needed value for their money. That means if you consult us to do solar installation for you or electrical installation, you get the best service that you can ever imagine. We keep abreast with the latest technology in the industry to always remain relevant in the industry. If you look at some of our signature projects, you understand what I mean. With the help of technology, we are strategically positioned to make our impact felt globally. That is the essence of this training. With the help of technology, we don't have any boundary. We'll make sure that our impact is felt in the entire globe. You will have our services rendered to you anywhere in the world. Subway Energy Academy is an innovative solar training academy. It is our training academy is not anyhow training academy. We teach with the latest innovation in the industry, one of the best you can trust, and this is our online training course. We are here to inform you, we are here to educate you, instruct you, guide, mentor, and above all, we want to contribute our quota to solving power problem and unemployment globally. Attending, listening to us, we guarantee you that at the end of this session, if you have any challenge with power problem, conventional or solar energy, the information we give out here will give you the needed guide on how to go about solving your power problem. With our in-depth theoretical and practical training that cut across all the sectors in the solar industry, our students will get to understand how to make wise and informed decisions in power generation and consumption. You are not only learning, you know how to generate power efficiently and how to use power efficiently and effectively. Our vision for the year is to train at least 20,000 interested individuals across the globe, online in solar energy and make sure at least 5,000 out of the 20,000 students are gainfully employed in the solar industry. We are not going to just train you, we are going to guide you on how to be gainfully employed in the industry in a special Telegram group. We put all these students together, train them on the business aspects of solar energy and how to be gainfully employed. We don't want our students to be writing employment here and there. With the information we are going to give here, you are guaranteed of living a life free from unemployment. This is our online training session. We run offline, that is the practical session. We run the blended training, a combination of practical and online training. And we run the virtual training. You can check us up on our website www.subwaylimited.com or www.c.subwaylimited.com. We are a people raiser. We are value enhancers. If you join our training, we give you the best value that you can get anywhere. We are motion propellers and we are mentors to many. It's a privilege having you. Welcome to this module, our services. We all know that the power sector as a discipline is very wide with different sections, but basically we are into solar system design. We start any project design by proper energy audit of the facility. We dwell on this on Solar Installation 101. We are in Solar Installation 102. After a proper power audit to ascertain the electrical loads that will be used on the solar components or the solar system, we go back to the office to design the different solar components that will be run with the solar components or the solar system, including your solar inverter, the solar battery bank, the solar panels, the charge controllers or controllers with the accessories that will be used during the installation process. During the power audit exercise, we take into consideration, because these are the things that will determine the size of any solar system. So we take into cognizance the electrical loads that will be used on the solar system or the solar components. We will take into consideration the roof information to ascertain whether the space available on the roof will be enough for us to mount the solar components or the solar panels. Then we look at the electrical architecture of the building to know how well the electrical architecture will suit into our design. whether there will be some amendments. We also take into cognizance the duration of usage of each of the electrical loads, as these will certainly affect our design. We consider the sun hours on the sites, and we ask the clients of how his electrical demand would be 3, 5 to 10 years after we might have finished our installation. This and other information that we have already discussed in Solar Installation 101 will guide us to design a solar system that cannot fail us. That is how we do it. After the design stage, we move into writing quotation and material selection. We use the best materials available from top solar manufacturers globally, irrespective of the price. Then we proceed to installation. We bring our professionalism to bear in our installation. If you have visited our website or our Telegram group, you understand what we are saying here. We pay attention to small details. In Solar Installation 101, we kept talking about small details. Small details with the requisite protection or protective measures. Our installation will never fail us, and it will give us the needed results we always yearn for. The solar components, like any other gadget, needs maintenance. We all know this. So we undertake maintenance of our solar components, or if you want to consult us to maintain your solar components for you, you can do well to contact us. This is to give us optimum productivity and durability. Solar components requires maintenance. If the components were properly designed and installed with proper maintenance, you are guaranteed at least a decade when we finish installing your installation for you. Your solar installation can take you for 10 years. We kept visiting our installation sites to check on our systems. That means we don't just abandon our clients to struggle with the system. It is our responsibility, our sole responsibility, because when the system give the clients the needed return on investment, our hearts, our mind will be at peace. So we keep visiting our sites to know how the components are faring. The solar industry cannot be complete without the conventional electrical industry. So, as part of our services, we handle general electrical design, and the process is as already discussed. We follow the same approach. We handle installation, and we as well handle maintenance. That means if you contact Subway Energy Limited or if you make Subway Energy Limited your preferred brand, you are guaranteed of the best installation when it comes to power generation. We handle sales of solar and electrical components. A visit to our website www.subwaylimited.com will shock you. We handle trainings and consulting. Our training platforms are among the leading training platforms you can ever imagine, with the latest and up-to-date information, as you will see in the course of this training. We are going to give you nothing but the best and the latest information in the industry. Our consulting services is superb. Just give us a call. Feel free, relax as we take you on a ride and reveal to you some of the hidden secrets in the solar industry. In this module, you are going to know your instructor. I work with Subway Energy Limited. I have benefited tremendously from this company. This company have impacted me with more than enough information, which I'm going to share with you in the course of this training. This is my brand. This is the company I would love you to partner with. Most of my friends know me as Asukas, but I am known in the business world as Asana, a graduate from the prestigious University of Calabar, Department of Geology. I'm passionate about renewable energy, and I have been in the industry for many years after graduation. An entrepreneur, a computer analyst, a publisher, and an author. I am an ardent researcher. I'll be your driver, your mentor, and a bridge builder in the course of this online training. I am passionate about being a blessing to somebody. What you will be learning. We are going to consider the solar panel in detail. We all know that the photovoltaic panel or the PV module is undeniably the major DC source for charging the solar battery. We know what the aim of using the solar battery is in the industry. So the solar panel is the integral part of any solar system. It is the backbone in the solar industry, and because of this, everything originates from the solar panel. And a proper understanding of the solar panel will help solve some of the solar system failures we are experiencing in the industry. Happy listening. Well, we are going to consider the solar panel. This is going to be a 2 days training. and we try as much as possible to use 2 hours in each of the session. And in the course of this training, we are going to consider the cell material of the solar panel. We are going to do just a brief introduction to the glazing material. We are going to consider the electrical parameters of the solar panels. We will talk about the IV curve of any solar panel. Then we talk about the solar panel nameplates. We will talk about monocrystalline solar panels, the polycrystalline solar panels, the amorphous solar panels, the PERC solar panels, and the CVP solar cells. We'll talk about solar panels connections and others. We'll talk about how to know the best solar panels to buy when you want to buy your solar panels. You get to understand how to differentiate between a fake solar panel and an original solar panel, or a manipulated solar panel nameplates. Some end users and installers have been asking us on some questions about how to classify the solar panel based on the voltage. You are going to get a clearer understanding of the concepts before the end of this training. So sit tight and listen to the end of this training. There's going to be a summary section. Questions will be answered if there is any. And this approach, after the training, you get to understand the detail about any solar panel you want to use during any solar system installation. Then you are going to learn about the several factors that affect the performance and the durability of solar panel, and the different approach we use when we are sizing our solar panels. You get to learn about solar panel efficiency and how to go about proper installation of any solar system, and why some solar systems are failing. Happy. Welcome to this module. In this module, we are going to do a brief introduction. We are going to introduce you to some of our signature projects. Here comes one of our signature projects. This is an industrial solar installation. This is the equipment room. The components are mounted on the wall. Here comes another installation, a commercial solar installation inside the equipment room also. You have here your Fronius inverters. We have 3 units here. We have your critical inverter here, the Phoenix inverter. It is rated 5 kVA. We have the Quattro inverters here. They are mounted on the wall. Each is rated 10 kVA. We have the charge controller here. We have the AC box here. We have the DC box. You can see how we run the cables. You can see how we run the cables here. This is your battery monitor. These are your communication devices. Your PHCN box. The system is fully automated. You can see your solar battery here. There are 24 in number. Each of the solar battery here is rated 2 volts, 1000 mAh with 4 terminals each. Equally, you can see from this other installation your Fronius inverter here, your critical inverter here. You can see how we run our cables here. You can see your AC box, your DC box, your charge controller, your communication devices are here, and your PHCN box is here. I've already said that the system is fully automated. You don't need anybody's intervention to start the generator or to off the generator. We have 3 phases here: the red, the yellow, and the blue phase. All of them comes up automatically during the daytime, and they switch off automatically at night. So without anybody's intervention, it's fully automated. The critical inverter runs for 24 hours. It is the inverter that takes care of the critical loads inside of the facility. This is a residential installation that we are having here. The inverter here is 5 kVA with 4 solar battery. Diagrammatically, this is your solar panels. Depending on the materials available on site, you can arrange your solar panels in string and in arrays. So that is one of the things you get to learn when you join our training. This is a 4x3 configuration. It is the solar panel that give the needed DC to charge your solar battery that you are having here. You can see your solar charge controller. It is what regulates the charging of your solar battery that you are having here, so that your solar battery will not be overcharged or over discharged or undercharged, and it protects the solar battery so that it gives you a longer duration of usage if it is properly sized. You can see your inverter here. It is what converts the stored DC inside of the solar battery here so that the energy can be converted to AC to power these electrical appliances. This is equally a 5 kVA system. Then you can look at the solar panel. This is what we are going to deliberate. We are going to dissect the solar panel so that you get to understand. You don't ask anybody any question again on the best solar battery to get for yourself during any solar installation or project you want to embark upon. What the information you get in this platform, even though you have 1,000 solar panels, you will know how to configure them to give you the needed power, the output that you will use, that you send to your charge controller or your solar inverter. Then from there, you get to understand how to size other solar components, your solar inverter, your solar battery, and your solar charge controller. You equally learn still in this platform how to size your cables, how to size your breakers. So we are loaded. The information you get here will give you an edge in the solar industry. Happy. Let's get started. In this module, we are going to consider some concepts. One of it is solar panel rating. What do we really mean by solar panel rating? In any vocation, there are ways we measure quantities. If we are talking about time, we know that we measure it in seconds. We can denote time by minutes, and we can denote time in hours. Those units help us communicate effectively in the industry. So, when you come to the solar industry, the solar panels are as well rated to help us communicate effectively. It is the rating of any solar panel that will help us understand how to configure it, how to connect it, and how to communicate when we are talking about a particular solar panel. So, solar panels are rated differently in the solar industry depending on the power requirements of such a solar panel. The manufacturers will sit down and think of the size of the solar panel they want to manufacture, and from there they will combine the cells. From the cells we have the module, and at the end of the day we have the solar panel. We talk about this in solar installation 101. So in the solar industry, we have solar panels that are less than 50 watts. Maybe you have seen smaller sizes of solar panels that are used in some of the solar kits that we have in our society or around us. We equally have solar panels of 100 watts. We have solar panels of 150 watts. We have solar panels of 250 watts, and so on and so forth. We have solar panels of 700 watts, and there are solar panels in between these ratings that we have put forward in front of you here. Then We also know that the solar panels are classified based on the cell materials. When we are considering the cell materials, we are talking about the material makeup of the solar panels, the silicon crystals that are used in the manufacturing process of each of the solar panel. It is what gives us the DC when they are exposed to the sun. Then solar panels are also classified based on the glazing materials, that is the frame or the casing that houses the solar cells. And we can as well classify solar panels based on the electrical characteristics of each of the solar panel. We will dwell more on the cell material of a particular solar panel because it is the cell material that gives us the different types of solar panels that we have in the markets, including the monocrystalline solar panels, the polycrystalline solar panels, and the amorphous solar panels. We will not dwell much on the glazing material. Then we'll take a look at the electrical parameters or the electrical characteristics of each of the solar panel, and this will take us to the IV curve of the solar panel, the solar nameplates, and the open circuit voltage, the short circuit currents, and the maximum power of any solar panel. With an in-depth discussion of each of these concepts, you will be able to professionally classify the solar panel. We will as well take a look at the classification of solar panels based on the voltage. We have solar panels of 12 volts and solar panels of 24 volts. It is this voltage rating that will enable us know exactly how to configure each of the solar panel, and this will help us know how to combine the different solar components that will give us the solar system. Welcome to this module. Here we will be considering the cell material. In our last module, we talked about how the solar panels are rated, that the solar panels are rated in watts. We have different wattage when we are talking about the solar panel. We know that the cell material is what gives us an impression or the basic characteristics of any solar panel, and it is an established fact that the most used cell material during solar panel manufacturing is the crystalline silicon, the sand that we have in our environments, the second most abundant element in the world. And During the manufacturing process, the cell material may be made up of single crystal. And when the cell material is made up of a single crystal, we have the monocrystalline solar panel. You can see this is the monocrystalline solar panel. We will take a look at the characteristics of the monocrystalline solar panels. We have another solar panel in which the crystal structure is made up of multi-crystals. And when the crystal structure is made up of multi-crystal, we have the polycrystalline solar panel. This is the polycrystalline solar panel. We will look at the characteristics of the polycrystalline solar panel and why you should choose the polycrystalline or this monocrystalline solar panel as your best choice. And we also know that the crystal structure may be made up of a thin film crystal that is thin enough to be flexible. And when we have such a solar panel, we have the thin film or amorphous solar panel. Based on these three categories of the manufacturing process of the solar panel, we have the different types of solar panels available in the market. The first type of solar panel we have is the monocrystalline or the single crystal structure that is made up of single crystal. And we have other solar panels that are still monocrystalline, but their efficiency is far more better than that of the main monocrystalline solar panel. And one of it is the passivated emitter and rear solar panel. Its efficiency is better than that of the conventional monocrystalline solar panel. And we have the CVP solar panel, that is the concentrated PV cells. We will take a look at the characteristics and why you should choose each of these solar panel for your project. And we also have the polycrystalline or the multi-crystal solar panels. And after the polycrystalline solar panels, we have the amorphous or the thin film solar panels. We are going to take a closer look at each of these solar panels and what should inform you of choosing each of the solar panel type during a particular solar system project. It is your understanding of the characteristics of each of these solar panel type that will inform you of how to make your choice during your solar projects. Welcome once again to this module. In this module, we are going to look at the monocrystalline or the single crystal solar panel. Here is your monocrystalline solar panels. The question now is, how do we differentiate the monocrystalline solar panels from the polycrystalline solar panels? And this will take us to the characteristics of the monocrystalline solar panels. What are those features that you are most likely going to see on a monocrystalline solar panel that will help you differentiate it from a polycrystalline solar panel and the amorphous solar panel? One of the characteristics of the monocrystalline solar panel is that they are made from single crystal silicon. During the manufacturing process, it is only one crystal. This is a cell, a solar cell. So during the manufacturing process of this solar panel, the crystal structure is made up of a single crystal, and that is what gives it its characteristics feature. Another characteristics of the monocrystalline solar panel is that they are dark in color. If you have noticed the polycrystalline and the amorphous solar panel, you will notice that the monocrystalline solar panel is darker compared to the polycrystalline solar panel. So those solar panels that are dark in color are the monocrystalline solar panels, and they are made up of rounded edges. You can see it here. These are the rounded corners that you can always see physically when you examine the monocrystalline solar panel. You can see the rounded corners, whereas the polycrystalline solar panels doesn't have the rounded edges. So one of the features is it is dark in color. And another thing you use and differentiate the monocrystalline solar panel, even if the nameplate is not on the solar panel, is its dark color and the rounded edges. Another feature of the monocrystalline solar panel is that it is the most efficient solar panel that we have in the market. It is the most efficient solar panel that we have in the market. Yeah. If you test the output of the solar panel that is monocrystalline, the output most times is higher than that of the polycrystalline solar panels, and their efficiency is most times, not most times, is always higher than that of the polycrystalline solar panel, as we will see in the course of this training. They are the most efficient and longest lasting solar panel. They are the most space efficient and longest solar panel. When you are talking about space efficiency or space efficient, that means if you are using 10 polycrystalline solar panels to have a particular output. You can use like 8 solar panels to have that same output. So they give you enough, you can always have less number of monocrystalline solar panels when you are designing your solar system because of its efficiency. There are the most costly solar panels. That means because of the quality, the efficiency that this solar panel will always deliver, there are the most costly solar panels in the market. These are some of the um, characteristics, features that help you or that will help you differentiate monocrystalline solar panels from the polycrystalline and the amorphous solar panels in the market. One is that they are made up of single crystal. They are dark in color with rounded edges. They are the most efficient solar panels, the most space efficient and longest lasting solar panels, and there are the most costly solar panels. In our next module, we are going to consider the polycrystalline solar panels. Thank you. Welcome to this module. In this module, we are going to consider the PERC panels, the passivated emitter and rear solar panels. There are basically the half-cut or half-cell solar panels. There are the improvements of the conventional monocrystalline solar panels, only that their efficiency is higher than that of the conventional monocrystalline solar panels because of the passivated layer that you see here. If you look at the normal monocrystalline solar panel, you will notice that there is no passivation layer in the conventional monocrystalline solar panel. The PERC have the passivation layer. So we are going to look at some of the characteristics of the PERC solar panels. Among the characteristics of the PERC panel is that they have the passivation layer at the rear surface, as can be clearly seen here. This is what gives rise to the high efficiency in the PERC solar panels. There are still the monopanels because of the manufacturing process. They are made of single crystals, but with the help of the passivation layer, the efficiency is greatly improved. The PERC panels allow greater solar energy collection in a smaller footprint. That means the space used during installation to mount the PERC solar panels will be greatly reduced because of its high efficiency as compared to the conventional solar panel. That is, we need a smaller physical footprint for the installation of these solar panels. The amount of solar radiation that get absorbed with PERC solar panel is much. That means that there's no reflection because light energy striking on this surface will get absorbed in the process, and there will be more absorption in the process. We move to another type of the monocrystalline solar panel, which is the CVP solar panel. Here is a picture of the CVP solar panel as can be seen here. So we want to take a closer look at some of the characteristics what make the CVP solar panel the most efficient solar panel. So we move to the characteristics of the CVP solar panels. There are the most efficient solar panels because of the mirror and curve surface on this particular type of solar panel. So they have curved mirror, as I have already said. They have curved mirror surfaces, lenses, and cooling system. That is what contributes to the high efficiency of this solar panel. They are incorporated with solar tracker that follows the sun direction. When you are talking about the solar tracker will move in proportion to the sun rays. That means as the sun is moving, the solar tracker will keep moving the solar panel so that it receives maximum insolation all day long as far as there is sun. So those are some of the characteristics that help us differentiate the monocrystalline solar panels, that is the conventional monocrystalline solar panels, the CVP solar panels, and the passivation solar panels. We move to the next type of solar panel in our list. Happy listening. In our last video, we talked about the monocrystalline solar panels. In this video, we are going to consider the multi-crystal solar panels. Here is the multi-crystal solar panels, and we are going to take a closer look at the characteristics of the poly panels. That is the characteristics of the polycrystalline solar panels. One of the characteristics of the polycrystalline solar panel is that they are formed from different crystals instead of one. You were exposed to the fact that the monocrystalline solar panels are made up of only a single crystal, and because of this we have the characteristics feature that we have in the monocrystalline solar panels. Here the polycrystalline solar panel is made up of multi-crystal structures. There are solar panels with squares and uncut angles, mostly blue. If you remembered when we were talking about the monocrystalline solar panels, you notice that it was made up of rounded edges and they were black or dark in color, whereas the polycrystalline solar panel is blue in color with squares and uncut angles. They are not rounded. So when you go to buy your solar panel and you notice that even though you don't look at the solar panel nameplate, you notice that the angles here are sharp. They are not rounded and they are blue in color. You have to know that that is a polycrystalline solar panel. They are less efficient when compared with the monocrystalline solar panels. We already said that the monocrystalline solar panel is the best and most efficient solar panel. So second in our list in terms of efficiency is the polycrystalline solar panel. So if you are using your polycrystalline solar panel, you cannot expect to have the same efficiency compared to when you are using your monocrystalline solar panel, and the costs cannot be the same. So when you are buying your solar panels, the polycrystalline solar panels will be cheaper than the monocrystalline solar panels because of its less efficiency. Then we move into the amorphous solar panel or the thin film solar panel. You can see it's more or less the structure here is made up of very fine layers. Then we proceed to understanding some of the characteristics of the amorphous solar panel. One of the property or the distinguishing feature of the amorphous or thin film solar panel is that they are characterized by very fine layers that are thin enough to be flexible. These panels don't have frame. If you have been opportune to get in touch or see this panel physically, you notice that it doesn't have any frame. So that is your thin film solar panel. I've already said that this solar panel doesn't have any frame. So there are thin film in nature. Thin film panels can come in different sizes. That is, unlike the monocrystalline and the polycrystalline solar panels, in which their cell come with standardized sizes of say like 60 cells, 70 cells, 96 cells. The thin film solar panels can come in different shapes and sizes to suit the application in which it is designed to be used. So it doesn't come in the normal cells 60, 72, 96 cells and so on. So they come because they are designed to meet a particular application. In terms of efficiency, there are the least efficient solar panel. there are the least efficient solar panel, and there are the cheapest in the market. So when you are considering buying your solar panel, you should always consider the efficiency of the solar panel, but you also have to bear in mind that the efficiency will always come with a cost. We have already said that there are the cheapest solar panels in the market because there are thin film and they are made of very fine layers. They can be easily fold. They come in foldable forms. They can be rollable. So these are all thin film solar panels. Those are some of the characteristics that differentiate the amorphous solar panels with other solar panels that we have. Let's consider the factors that inform us of the choice of any solar panel. On our list here, the first factor that will determine the type of solar panel that you get for your installation is the budget. How much do you budget for your solar panel? Can you afford the high efficient solar panel? How much did you collect your clients to put into buying the solar panels? How much is your client willing to give out for the purchase of the solar panel? Because when we were talking about solar panels efficiency, you were made to understand that the high efficient solar panels come with a price. That does not mean that the polycrystalline solar panels with a lower efficiency are not good when considering solar system installation. They will still deliver optimally, but when you compare the outputs and the efficiency with that of the monocrystalline solar panels, the monocrystalline solar panels are better off. So the first factor that determines the type of solar panel you get for your installation is your budget. The second factor that determines the type of solar panel that you get for your installation is the application to which it is meant for. If you consider a commercial solar installation in which the electrical loads will be much, it's pertinent to go after high efficiency solar panels. But when you are considering a residential solar installation in which the electrical appliances might not be much, it's wisdom, depending on the budget, to go after the polycrystalline solar panels. So the application in which the solar panel is meant for greatly determine the type of solar panel that will be used. Another scenario is if you are installing a commercial installation in which the roof space will not be enough to mount much solar panels. It is wisdom to go for high efficient solar panels irrespective of the cost. Those are some of the things you need to consider when you are choosing your solar panel. Another thing, another factor that determines the type of solar panel is your understanding of how that particular solar panel works. When you are considering the thin film solar panels or the CVP solar panel, we know that the CVP solar panels will definitely need solar tracker for it to deliver the needed efficiency of such a solar panel. But in a situation in which you don't incorporate a solar tracker into the solar panels during installation, it might not give you as expected. Another thing is, if you are using the thin film solar panels, it's most importantly used where the building, the space inside of the installation does not allow the use of rigid solar panels. Rather, it allows for the installation of flexible solar panels. And in such condition, you can go for the thin film solar panels. Those are some of the factors that will inform you of the type of solar panel to use when you are embarking on any solar. We are considering the solar panel terminals in this module. That is the solar panel probe. Here are This is the solar panel probe. As you can clearly see it here, they came pre-wired from the manufacturers. This is a half-cut solar panel. You can see the position of the solar panel probe. Why do we consider the solar panel probe in this training? If you have been in the industry for quite some time, you will notice that the solar panel probe is the major part of the solar panel that first will need maintenance before you can think of maintaining other components after installation. So it's very important as a professional to always be able to differentiate an original probe from a fake probe. The main solar cells or the solar panel itself may be or might be an original solar panel, but the probe, the connection here that gives the outputs, might tend to give you headache after installation. And when such happens, the solar panel will not be able to deliver the needed outputs that it's meant to deliver. So most times when we hear that the solar system is not charging, the first part we love troubleshooting first is to check the probe whether anything has happened to it, because if they were fake probes, certainly the solar panel will not deliver the needed output. So as a professional, you should be able to differentiate an original solar panel probe from a fake solar panel probe. And you should know that the solar panel probe is often the first part of the solar panel that will quickly need maintenance before you can think of doing the minor maintenance of the solar panel itself, maybe watching each module. You should know that each module, each solar panel come with a positive and a negative probe, in which you connect it whether in series or in parallel. We will get to that with another solar panel to give you the needed output. And if you happen to meet or to see some solar panels, you know that some of the solar modules come with junction box, as you can see here, with knockout holes for conduits to enter. That I've already said that this particular panel is pre-wired to give us an easy access or the ability to connect this solar panel as fast as possible. So, as a professional, try and understand how to differentiate a fake solar panel from an original solar panel. Then when you hear that your solar panel is not, your solar system is not charging, basically, most times what we first troubleshoot is the solar panel's probe before we can think of troubleshooting other components if we notice that the solar panel probes are still okay. So do well to do justice to this when you are buying any solar panel. Welcome to this module. In this module, we are going to consider the solar panel efficiency. You have been hearing us making reference to efficiency. You might be asking, what is efficiency? So we have to throw some light, do some explanation of what efficiency is all about. When we are talking about efficiency, we are talking about the percentage of work put into a machine by the user. That is the input work that becomes work done by the machine, the output work. If you were a good science student, this topic was treated in physics. For those people that were physics students, they'll get a clearer understanding of what efficiency is all about. In real life, you cannot give all that you have. If you have $100 and somebody come to you to borrow money, you will definitely not give out the entire $100 if that is your last money. You will reserve some for yourself in case there is any emergency. The same applies to the machine that we use. If you will be opportune to join us in our masterclass, we will deliberate more on efficiency, because when you are talking about your solar inverter, you have to be very familiar with the efficiency of the inverter. So the output work is always less than the input work, because some of the input work is used to overcome friction. There is no machine that is frictionless. The parts will certainly experience friction, and during the friction process, some energy will be wasted as heat, and they might be transformed to other form of energy. Therefore, efficiency is always less than 100%. When we are talking about efficiency, if you join us in a master class, we'll talk about the power factor of a machine, of an inverter, whether the power factor is 0.8 or a unity power factor. So the efficiency that we have when we are considering any solar component is how close the output work is close to 100%. So we are saying that efficiency is always less than 100. The closer to 100% a machine is, the better it is at reducing friction. A frictionless machine would have an efficiency of 100%. That is a brief introduction of what efficiency is. And we know that no machine is 100% efficient. And that means energy put into a machine cannot be equal to energy output of a machine unless the machine is a frictionless machine. Irrespective of the fact that the machine is a frictionless machine, it cannot give you 100% efficiency. So, solar panel efficiency defines the rate at which a given solar panel turns sunlight into electricity. There is always a formula associated with calculating efficiency. If you make reference to your physics, you know that your efficiency is the output work divided by the input work multiplied by 100. If you put those parameters into the formula, we are not here for calculation yet. If you are given some parameters and you substitute them into this formula, it will give you the efficiency of a particular machine or a gadget. But let's move to another topic which is of interest in this context. We have to consider the factors that affect the efficiency of a solar panel. What are the factors that affect the efficiency of a solar panel? We talked about the cell material of a solar panel. The cell material of any solar panel will always contributes to the efficiency of a solar panel. We talked about the monocrystalline solar panels, the polycrystalline solar panels, and the amorphous solar panels. The manufacturing process is what determines the efficiency of those solar panels. The planning, how do you plan the installation? There are some people that call us, this panel is not generating as expected. How did you connect it? Is it in parallel or is it in series? So those are the things that also contribute to the efficiency, the output that you get during your installation, the planning stage. So we also know that the installation, how do you install your solar panel? This is also a contributive factor when you are considering the efficiency of a solar panel. You also have to know that how do you maintain your solar panel also give you an impression of the output that your solar panel will also give. These and more are some of the factors that affect the efficiency of any solar panel. We are moving to an interesting part of this training, which will talk about the electrical parameters of the solar panels. In this module, we are going to only introduce you to the concepts, the things that we are going to talk about before getting into the details. In this training or in this module, we are going to consider the classification of solar panels based on the voltage. There has been some condition in the industry. Some people don't understand how to classify the solar panels based on the voltage. So this is our solar panel here. This is our charge controller here. And this is the nameplate. You will get to understand what the nameplate is. And this is the connection of this type of solar panel. It's a 12-volt solar panel, and we are having a 12-volt 100-watt mono solar panel here. We are going to consider a 24-volt solar panel, because when we are classifying the solar panel, in terms of voltage, we have 12-volt solar panel and 24-volt solar panel. You get to understand why we have those two classifications in the course of this training. This is a 24-volt solar panel, and we are having a 24-volt charge controller here. This is a PWM charge controller, whereas this is an MPPT charge controller. We are not considering the charge controller here though, but the MPPT charge controller is far more better than the PWM charge controller. We get to understand that in the next session of our training. This is the electrical connection of this 24-volt solar panel, and here comes the nameplates. We are going to consider all those in the course of this our discussion. We are going to consider the IV curve of a solar panel, because it is the IV curve that will give us the results that we will be having on the solar nameplates. The IV curve will be expatiated for you to understand what we mean by maximum power and voltage at maximum power, the current at maximum power. You get to learn about short circuit currents and open circuit voltage of any solar panel and what they really mean. This is an IV curve of a 12-volt solar panel. Then we'll get to understand in detail the nameplates and the parameters that we are having on the nameplates here, so that when you get to design a system, we are not going to do system matching here. We are not going to talk about configuration of how to combine the charge controller, the solar battery, and the inverter to have a full-blown system. But we are going to do justice to the nameplates here and the parameters here and what they mean, so that when you want to get any solar panel for your installation or when you are designing a solar system, you understand the parameters you have on the solar nameplate. This is a 12-volt solar panel nameplate. It's a sun power product. We are going to do justice to the nameplate of a 24-volt solar panel, so that you will comfortably understand what differentiates a 12-volt solar panel from a 24-volt solar panel. And with this understanding, you will be able to make wise and informed decisions when you are designing a system for yourself or for a client, because it's not about the size of a solar panel. It's not about the make of a solar panel. It's always about the nameplates that each of the solar panel comes with. Though there are some fake nameplates in the market, we are going to expose you to how you will test to know for sure that this nameplate you are having on this solar panel depicts the output that you have when you use a solar panel. This and other things are what we are going to expose you to in the course of this training. Welcome. This is Subway Energy Academy, one of the leading training academy you can trust. If you attend our paid version, our master class, you get the detail to each and every other information you need in the solar industry. Welcome to this module. In this module, we are going to take a closer look at the electrical parameters of the solar panel, and we are going to look at the classification of the solar panel based on the voltage. The voltage is the driving force that pushes the current or the potential difference that exists between the positive and the negative terminal of the solar panel. And there has been some confusion in the solar industry, even with professionals. So we want to get this information across to you so that you understand how to classify the solar panel based on the voltage. Basically, we have two types of solar panels when we are talking about the solar panel voltage. We have been hearing some people say this solar is a 48 volt, a 50 volt solar panel, a 36 volt solar panel, a 45, or as the case may be. No, we don't have a 50 volt solar panel. That is the open circuit voltage of that solar panel, as we will make you understand in the course of this training. So when you look at any solar panel, basically we have two types of solar panel when we are considering the voltage of a solar panel. We have a 12 volt solar panel and we have a 24 volt solar panel. We don't have a 48 volt solar panel, but we have a 48 volt system. We will get to understand this as we progress. Why do we say that we have two types of solar panels when we are considering the voltage of a solar panel? Basically, before now, we have systems that are 12 volts. We have a 12 volt system, we have a 24 volt system, we have a 36 volt system, we have a 48 volt system, we have a 96 volt system. We get to understand this as we progress in this training. Why do we say that we have a 12 volt system? If you take a closer look at this picture before you, you will see this solar panel here, and you see this charge controller before you. If you take a closer look at this other picture that I have projected here, you see this inverter and you see this battery. Then the question is, why do we say that we have a 12 volt system or a 12 volt solar panel and a 24 volt solar panel? We don't have a 48 volt solar panel or a 50 volt solar panel. All those ratings that you are seeing, there are open circuit voltage of the solar panel. If we are classifying the solar panel, we have either a 12 volt solar panel and we equally have a 24 volt solar panel. The issue is, if you look at this system is a 12 volt solar inverter and this is a 12 volt solar battery and this is a 12 volt charge controller. In this scenario, you certainly need a 12 volt solar panel to charge this battery and equally to work with this inverter that you are having here. The issue is, when you are talking about your solar panel, we have cells. You can look at this. This is a solar cell, and you know that each solar panel is composed of photovoltaic cells. These are the different cells of this particular 12 volts solar panel, and we have 36. If you count these cells here, you will notice that there are 36 in number, and each of the solar cell here is 0.5 volts or 0.45 volts. And if you connect this in series, you will certainly have a voltage of between 15, 17 or 21 volt, depending on the intensity of the sun. So because we need to charge a 12 volt system, you certainly need a 12 volt solar panel to use for the purpose of charging this uh, 12 volts battery and to work with a 12 volt inverter and equally to work with a 12 volt charge controller. If you are using a 24 volt solar panel, it will blast this charge controller because it's not a 12 volts or a yes, it's not a 12 volt solar panel you are using with it. So we will destroy this solar charge controller. Equally, it will destroy this particular uh, inverter that you are having here, and it will equally destroy this battery. So in that case, you need a 12 volt solar panel to be used during your configuration for the purpose of combining it with these uh, components that are 12 volts as they are rated by the manufacturers. So we have a solar panel that is 12 volts for the purpose of charging 12 volts solar component, so that it will not destroy it. And we equally need a 24 volt panel to charge solar components that are equally 24 volts as rated by the manufacturers. That is the reason we are having a 12 volt and a 24 volt solar panel. Every other panel that you are seeing or the voltage rating you are seeing on the nameplate of the solar panel are open circuit voltage. There are open circuit voltage. We are going to consider that in the course of this training. We still continue with the 12 volts solar panel. If you look at the nameplates of a 12 volt solar panel, some manufacturers might choose to write it 12 volts so that it will be easy for end users to know that that is a 12 volt solar panel. But that does not mean that when you expose the solar panel to the sun, it will generate 12 volts. No, it is called 12 volts because we use it to on 12 volt solar components. It is called 12 volts because you use it with a 12 volt solar charge controller. It is called 12 volt because you will need to use it with a 12 volt inverter. It is called 12 volts because you need it to charge a 12 volt battery. But in reality, the voltage is more than 12 volts. If a solar panel is exactly 12 volts or 24 volts, as you may think, for a 12 volts or a 24 volt solar panel at open circuit voltage. We will talk about open circuit voltage. Open circuit voltage is the voltage that this solar panel will generate when it is not connected to any load. So if this solar panel is 12 volts at open circuit voltage, it will not be able to charge this solar battery. A scenario is if if you are fighting with somebody that the power is less, or if you are fighting with a smaller creature, maybe somebody that is of a lower age with you, you will be able to overpower that person. The same thing is applicable here. If this solar panel is the same 12 volts with this solar battery, when you connect this solar panel with this solar battery, there is going to be a voltage drop. There is certainly going to be a voltage drop when you connect the solar battery with the solar panel. So this 12 volt solar panel will not be able to charge this 12 volt solar battery if it is 12 volts, that is the same rating with this solar battery. Then that means this voltage will not be able to track the load that will be connected to it or to them. As such, the voltage of a 12 volt solar panel, that is the output voltage, must be higher than that of this solar battery or this solar inverter for it to adequately charge this solar battery. That is what is happening. As such, a 12 volt solar panel with 36 cells, I've already said that this is, if you count the cells here, it is 36 with 0.5 volts. I've said that this is, each of the cell here is 0.5. For each of the cell is between 17 to 21 volts. I've already said that. If you measure the voltage of this 12 volts solar panel, you see it 17 to 21 depending on the intensity of the sun at open circuit voltage. That will be the only scenario in which it will be able to adequately charge this solar battery. And for a 24 volt, when we get to a 24 volt solar panel, you get a better explanation to this. So when we are considering a 24 volt solar panel, the voltage, the cell arrangement might be 60 cells, 72 cells. So and each of the cell equally is rated 0.5. And when you expose it to the sun, you see a voltage range of about 36 to 50 volts at open circuit voltage, and that will be the voltage that will be able to charge a 24 volt system adequately. So that is the reason you hear us say that this solar panel is a 12 volt solar panel, because it will be used to charge a 12 volt solar battery, and it will be used on a 12 volt solar charge controller and on a 12 volt solar inverter. That is the reason we are saying that panel is a 12 volt solar panel. If you join us in a master class, we'll get to understand what we call the nominal voltage of an inverter. So that voltage that you are seeing is the nominal voltage of the solar panel. We have already said that is the number of solar cells in a particular solar panel can be less than 36 cells. It can be more than 36 cells as the case may be. It can be 36 cells, it can be 42 cells, 48 cells, it can be 60 cells, for the 24-volt solar panels, it can be 90 cells and above that. That means a solar panel consisting of 32 cells typically can produce between 14.72 volt. That is the open circuit voltage. Each is 0.5 or 0.45. If you approximate this, you have 0.5 volt. Each of the cell will produce that. And when you multiply that, it gives you a range of 14 point or 15 point something to 21 volts. That is the reason we say that panel is a 12 volt panel. We are going to do justice to a 24 volt solar panel so that you understand why we say that solar panels are based on voltage. Your solar panel can either be a 12 volt solar panel or a 24 volt solar panel. Join me in our next module. Welcome to this module. We want to continue from where we stopped. We talked about a 12 volt solar panel in our last video. Here we are going to consider a 24 volt solar panel. We know by now what a cell is. This is a solar cell, and there are 8 in numbers here, and there are 12 in numbers here. If you multiply it, you have 96 cells. 96 cells. Each is 0.5 volts. And if you do your calculation, you have a voltage range. You have a voltage range of maybe 36 to 50 volts, depending on some factors. So this is a 24 volt solar panel. And if you are doing your system configuration, you cannot buy this 24 volt solar panel to use it with a 12 volt solar charge controller. Mind you, I made mention of this in our last video. And you, depending on the charge controller you are using, this is a 24 volt charge controller equally, and this is the reason this solar panel is called a 24 volt solar panel, because it will be used with a 24 volt solar charge controller and on a 24 volt system. We are having 2 batteries here. If you can see, we are connecting it in series. This is the positive terminal of this particular battery, and we link it to the negative terminal of this other battery. And when you connect it like that, it gives you a potential difference of 24, and we use it with this 24 volt system. So that means if you are using 2 solar batteries, you certainly need a 24 volt solar panel with a 24 volt charge controller. That is the reason this solar panel is called a 24 volt solar panel, because it will be used with a 24 volt charge controller and a 24 volt inverter with 2 solar batteries connected in series. If you connect them in parallel, it will not give you a 24 volt. So you have to connect it in series. So that is the reason we are calling this solar panel a 24 volts solar panel. But at open circuit voltage, when this solar panel is not connected to any load, it will give more than 24 volts. It will give a range of say 36 to 50 volts depending on the intensity of the sun, depending on other factors which we will discuss in the course of this training. So that is the reason this solar panel is called a 24 volt solar panel. That does not mean that it generates 24 volts. It is called 24 volt because it is used on a 24 volt solar charge controller and a 24 volt solar inverter and a 24 volt solar battery. I'm repeating this for emphasis. And if you count the number of solar cells here, you have 96 in number. So a 24 volt solar photovoltaic panel generally consists of 60 cells, 72 cells, and above. If you count the number of cells here and it is more than 36, know that that is no more a 24 volt, a 12 volt solar panel. It has moved to a 24 volt solar panel. So let's look at a 48 volt system. Before now, we used to have a 36 volt solar inverter. We used to have, but it's not rampant anymore. We used to have a 96 volt solar inverter, but it's no more rampant. So we are having basically a 24 volt solar panel, and we also have a, a 12 volts solar panel. So this is a 48 volt solar inverter. You can see we are having 4 solar battery here. How are they connected? For us to have a 48 volt nominal voltage that will at least power this inverter, we need to connect this solar battery in series. We need to connect this solar battery in series. We will talk about this in the course of this training. So you can see here, this is a 48 volt system, and you are connecting this solar battery in series to power this solar inverter. In that case, all you need to do is to buy many solar panels. Each of it might be 12 volts. You connect them depending on the configuration you need. You connect them as many as possible depending on the rating of the inverter, the charge controller, and the battery. As you can see, the solar panels here, there are much. For it to adequately charge this solar battery, you need many of them. You don't need only one 24 volt solar panel. You need many of the solar panel so that it will adequately charge the solar battery. It depends on your design. It depends on the load that your system will power. Most times you see us use 8 solar battery. That is a design. It depends on the electrical load on the facility. So as you see, this number of solar panels, they were properly sized to take care of the loads in that facility. That is the reason you hear us say a solar panel can either be 12 volts or 24 volts. Any other thing you are having is the open circuit voltage. And if you need a 48 volt system, you connect them in series or in parallel depending on your configuration. Before now, we used to have a 96 volt solar systems. is no more rampant. So if you're having 8 solar battery, you still configure your solar panels to charge the battery effectively. We are not going to dwell much on that in the course of this training, but if you come over to our master class, we will consider that. That is how we classify solar panels based on voltage. Welcome to this particular module. In this module, we are going to expose you to how you are going to know a 12-volt solar panel by physical examination and by testing. Maybe you use your multimeter. How do you go about that? Let's consider how we are supposed to know that this panel is a 12-volt solar panel. The number one thing that you have to do is if you look at the first figure that I am having here, you look at it, and if you count the number of cells, you discover that there are 36 cells. There are 36 cells. Each is 0.5 volts. So by physical examination, we are saying this is the cell arrangement of a 12-volt solar panel. So by physical examination, if you count the number of cells that you are having here physically, you get to know that it's going to give you 36 cells. And when you have that, when you count the number of cells and it's sum up to 36 cells, know that that is a 12-volt solar panel. I repeat, if you count the number of cells on the solar panel and it sums up to give you 36 cells, that means that that solar panel is a 12-volt solar panel. And if you need a charge controller to charge a battery, maybe you are having one solar battery that is 12 volts, you need a 12-volt charge controller to use it with a 12-volt solar panel. And maybe if you turn the nameplate of a 12-volt solar panel, you are most likely to see a voltage range depending on the manufacturer. You can see here open circuit voltage. That is, we already said that open circuit voltage is the voltage that you have when this solar panel is not connected to any load. So if you test this solar panel when it is not connected to any load, you are most likely to have 24 volts. But if this solar panel is connected to a load, you have voltage at maximum power. We will talk about this anyway. So we say that when it is connected to a load, there will be a voltage drop. So it's most likely if this solar panel, a 12-volt solar panel, is connected to a load, you have a voltage of less than 24 volts, because this was open circuit voltage when it was not connected to a load. But when you connect it to a load, maybe voltage, we say voltage at maximum power, you are most likely to have a voltage drop of say 17 volts. This is the electrical connection. The electrical connection of this particular 12-volt solar panel, you see, they are connected in series. This is the panel probe. This is the cells arrangement. You see, positive to negative, positive to negative, positive to negative. And when you sum up the voltage at the end of the day, you might have like 19.8 volt depending on the manufacturer. So how do you know a 12-volt solar panel? The number one thing you have to do is to count by counting the number of cells. And you know that a solar panel with 36 solar cells, there are 12-volt solar panel. Number two way of knowing that this panel is a 12-volt solar panel is by observing the specification on the nameplate. Solar panels of 50 watts to 200 watts are 12-volt solar panel. If you look at a solar panel that is 500 watts, that is not a 12-volt solar panel. So solar panels that are maybe 50 watts to 200 watts, there are 12-volt solar panel. That is when you look at the nameplates. Then solar panels from 17 volts to 21 volts at open circuit, there are 12-volt solar panels. Then another thing is, if you know the current rating and the peak watts on the nameplates, if you do your division, you should have a voltage that will give you between that will approximately inform you that that panel is a 12-volt solar panel. We know that power is always equal to IV. So if you know the current and you know the power of of the rating of the solar panel, if you do your calculation, you are most likely to see the voltage of that particular panel after your calculation. So these are the ways you'll be able to differentiate a 24-volt solar panel from a 12-volt solar panel. One is by counting the number of cells. And if you count the number of cells, you have like 36 cells. That depicts a 12-volt solar panel. By observing the nameplates, if you turn the nameplates of the solar panel and you see the wattage is maybe 150 watts, it's a 12-volt solar panel. If you look at the open circuit voltage and the open circuit voltage or voltage at open circuit, then you see a voltage within the range that I have already expatiated on. You know that is a 12-volt solar panel. Those are some of the ways. You can use your probe to test this equally. You use your probe, your multimeter, to test it, and you see the voltage reading on the multimeter. That is the way out. That is how to know that this panel surely is a 12-volt solar panel, and it will be used with a 12-volt charge controller and a 12-volt system. Welcome to this module. Here we are going to expatiate on how you get to know that this solar panel is a 24-volt solar panel. You can see before you here is a 24-volt solar panel. We have already said that your solar panel can either be a 12 volts or a 24-volt solar panel. So this is a 24-volt solar panel. This is another 24-volt solar panel. Be it a monocrystalline or a polycrystalline solar panel, it can be a 12 volt or a 24 volt solar panel. Then if you are using a 24 volt solar panel, you need a 24 volt charge controller. If you are buying a 24 volt solar panel and you are buying a 12 volt solar charge controller, it will not charge the system. So when you are buying a 24 volt solar panel, you need a 24 volt solar charge controller. We have already said this. This is PWM charge controller, and this is MPPT charge controller. When we get to charge controller, we will expatiate on the advantage of using MPPT charge controller over PWM charge controller. And we already said that a 24-volt solar panel will always have 60 cells, 72 cells, 96 cells, as the case may be. So here is the cell arrangement. You can see this is a positive terminal of this particular cell and negative. So you look at this arrangement, they are connected in series. Each of the cell is 0.5 volts, a 72 cell solar panel, and each of the cell is 0.5 volts. When you multiply that with 72 cells, you have approximately 36 cells, 36 volts rather. Then, depending on the intensity of the sun, you might have a voltage range. So that is what you know, and that is how you can differentiate a 12 volt solar panel from a 24 volt solar panel by counting the number of cells. If you count the number of cells here, you are most likely to arrive at 72 cells. And this solar panel is a monocrystalline solar panel that is 200 watts. A 12 volt solar panel and a 24 volt panel, the wattage overlaps. We can have a 24 volt solar panel that is 200 watts, and we can equally have a 12 volt solar panel that is 200 watts. If you look at this other solar panel, it is mono with 90 cells. This is the nameplate of the 24 volt solar panel with 335 watts power. Then other parameters are equally shown here. We will take a closer look at the solar nameplate in the course of this discussion. You can see here, this is the short edge and this is the long edge. You are having 6 cells in the short edge here, and you are having 12 cells in the long edge here. So we can say this is a 12 by 6 solar panel based on the cells arrangement. That is how to go about that. So we already said that if you count the number of cells and it gives you 60 cells, 72 cells and above, you have to know that that is a 24-volt solar panel. Then if you look at the panel rating, I've said that a 12 volts and a 24 volts, the wattage might overlap. That is, we might have a 12 volt that is 200 watts and a 24 volt that is 200 watts. So we have voltages, wattage of 200 to 600 and above. If you look at the nameplate and you have the wattage rating is above 200, that means that is a 24-volt solar panel. And if you look at the VOC is within this range, 36 volts to 50 volt. That is open circuit voltage of the solar panel on the nameplate. That is a 24-volt solar panel. Then another thing is, if you know the rated current and the wattage of the solar panel, you can do as I have already explained, and you can equally use your voltmeter or your multimeter. If you are a professional solar installer, you have to always go with your multimeter when you want to buy any solar panel. Forget about the nameplate. The nameplate might be deceptive, might deceive you. The nameplate might deceive you. I don't want to say more than that. So to be on the safe side, because if you are buying the solar panels with a fake nameplate, it will destabilize your installation. It will not give you the needed output that is required to charge your solar battery. And if you kept using the solar battery, it will spoil before the warranty expires. So it's always good to go with your multimeter, so that when you want to buy the solar panel, you at least test it. That is the best way. That is the best way. I repeat, that is the best way that will guarantee you, that will give you the assurance that the rating that you are seeing on the nameplates is what the manufacturers gave when they manufacture the solar panel. So the best way to know that for sure this solar panel is 600 watts is always good to test it with your multimeter. That gives you 100% assurance that this money that you are paying, you are getting the value worth of that rating of that solar panel. Thank you. Welcome to this module. In this module, we are going to take a look at a half cut or a half cell solar panel. We made mention of the PERC monocrystalline solar panels, that there are improvements from the conventional monocrystalline panels. So if you see a panel that you are having the probe at the middle of the solar panel and you have this demarcation, there are half-cut solar panels. So your half-cut solar panels are improvements from conventional monocrystalline solar panels. In half-cut solar panels, the solar cells are cut into half of its original size. You can see it on the picture here. So a half-cut solar panel is normally made up of two parts. We are going to expatiate on that. Why we have the two parts and how the connections are done. We said before now that the efficiency of the PERC panels are higher than that of the conventional solar panels. So performance wise, half-cut cells will help increase cell efficiency by a percentage. Then you have to know that the half-cut solar panels are more physically durable than their traditional counterparts. If you are talking of durability, the half-cut solar panels are more durable than their conventional counterpart because the sizes of the solar cells are reduced. The sizes of the solar cells are reduced. There are half of the normal conventional monocrystalline solar panels. And when the sizes are reduced, there are more resistance to cracking. That means there are resistance-wise, there are more resistance to cracking than the conventional monocrystalline solar panels. And you know that when the solar cells are smaller, they tend to the mechanical stress on each of the solar cell here will be reduced. They will be reduced and they will give a higher output. We are going to look at how the connection here is done and how that leads to a better output that we are having with the PERC or the half-cut solar panels. If you look at diagrammatically, if you look at this electrical connection, you are having two sections. You can see here that you are having two sections with 60 cells. This is the first half. If you count the number of cells here, you have like 60 cells. Each of the cell here is 0.5 volts. And if you look at the second half here, you are equally having 60 cells. What really happened is the first half here, they are connecting the solar cells here in series. And you know, when solar cells are connected in series, the voltage will definitely increase. And the same thing happened to this second half. They connect the cells here in series. After connecting the first half here in series, you have 30 volts, and the second half here is also connected in series, and you equally have 30 volts. After that, that means you have gotten 30 volts. After that, the first and the second half are connected in parallel. And when you connect solar cells in parallel, the voltage will remain the same, whereas the current will increase. When the current increase, that means when you multiply the resultant, the final increase in the current and the voltage, That is what happened. But in a conventional solar cells, they are all connected in series. But when we are talking about the half cell solar panels, the solar cells are half cut and it has two sections, the first section and the second section. The first section they are connected in series, the second sections are connected in series. After that, the two sections are connected in parallel to increase the power output of the solar panel. And if you look at it here, that means we are having about 120 cells when you are talking about this, and you are having about 550 watt solar panel. What is the advantage of a half cut solar panel as compared to the conventional solar panel that we have? The first advantage is that the panel will have higher output. From the illustration that was before you, you can see that it will always have a higher output. There is a 5 to 20% lower space requirement. That means if you are using the conventional monocrystalline solar panel, you might tend to use a bigger space, a bigger roof size, or if you are using stanchion, you might end up constructing a larger stanchion. But when you are using a half-cut solar cell, that the efficiency is increased. It tends to lower the space requirement. There is durability. We have already said that there are more resistance to cracking because the solar cells are reduced, so they are more durable. And even we know that when you are talking about a solar panel, the temperature that the solar panel is subjected to most times affects the productivity of the solar panel. So half-cut solar panels are more durable when compared with the conventional solar panel. Welcome to the Ivy Curve module. We said something about the Ivy Curve before now. So we are going to dissect the Ivy Curve of a solar panel so that when you look at the solar nameplates, you can understand what happened before those parameters are recorded. If you are talking about any solar panel and you don't understand the Ivy curve, I believe there is problem somewhere, or you don't understand the solar nameplates. There is always a problem somewhere. The Ivy curve is plotted in the laboratory under certain condition. The parameters on the nameplates are not recorded in an open field. Those parameters are conducted in the laboratory when the solar panel is subjected to some constants, and the values gotten when you subject the solar panels into those conditions are recorded. We heard about Boyle's law and Child's law. When those experiments are carried out or when those experiments were carried out, they were carried out in the laboratory under standard conditions. So when you look at the nameplates of any solar panel, those readings that you are seeing are gotten under a controlled environment. It's not conducted in an open field. So it's not possible to have those conditions in an open field. So here is your IV curve. This is an IV curve of a 12-volt solar panel, and you know that the IV curve is always plotted, the voltage is always plotted along the horizontal plane, whereas that is the horizontal axis, whereas the current is plotted along the vertical axis. If you are talking about any solar panel, the solar panel IV curve characteristics will always show the current voltage characteristics of the photovoltaic solar panel. The IV curve, I have already said that the IV curve will always give you an in-depth knowledge of a solar panel's conversion ability and efficiency. That is, a proper understanding of the IV curve of a solar panel is critical when determining the panel outputs and efficiency. When you are talking about the IV curve, it is what normally gives us an impression as to the output of this solar panel. We are going to delve into maximum power points of a solar panel, the voltage at maximum power point, the current at maximum power point. This is the point A, and we are going to talk about the short circuit voltage of a solar panel, and we are going to talk about the voltage, open circuit voltage of a solar panel. The IV curve is conducted in the laboratory at standard test condition. What do I mean by standard test condition? That means there are some parameters that are kept constant before the nameplate. The parameters on the nameplate are recorded. That means the solar panel was conducted under the parameters on the solar panel was conducted under a standard test condition. So when we are talking about standard test condition, the solar panel will be subjected to a 1000 watts per square meter irradiance or illumination. What do we mean by that? That means the amount of solar energy per unit area arriving on a surface of a particular solar panel at a particular angle. Then there is always a cell temperature that the solar panel will be subjected to. The solar panel cannot be, we already know that the cell temperature of a solar panel greatly affects its performance. When the illumination is small, the solar panel might tend to produce a lower power as against when the cell temperature is a bit higher. And when you subject your solar panel to a very high temperature, it might tend to affect the efficiency of the solar panel. we will still get to understand this. And a 1.5 spectral condition. When we are talking about spectral condition, we are talking about atmospheric temperature or pressure of the atmospheric condition that the solar panel is subjected to. So these are some of the standard test conditions that any solar panel that the manufacturers produces, depending on the company. These are the conditions that the solar panel will be subjected to before, when a particular result is gotten, those results will be put on the nameplate to tell you that if you are able to subject that particular solar panel to such a condition or conditions, the rating of that solar panel is exactly what you have. So, in essence, there is always a variation in what you have if you test those parameters in an open field. If you test those parameters in an open field, you are not certainly not going to have exact figures on the nameplate. So because you have not been able to subject the solar panel to the standard test condition that it was subjected to during production. So that is what Ivy Curve is all about, and that is how the parameters on the nameplates came about. Welcome.